video, we are going to explain about a project titled Glaucoma Detection using Deep Learning. Our project focuses on addressing the urgent need for early glaucoma diagnosis to prevent irreversible blindness. We aim to create a strong and reliable glaucoma detection system by utilizing the state-of-art deep learning techniques. Our approach involved training the convolutional networks on the large dataset of the retinal images to achieve exceptional sensitivity and specificity in identifying the glaucoma cases. The successful implementation of this project could revolutionize the glaucoma diagnosis, offering the eye care professionals an automated and trustworthy tool for early detection. By enabling the timely intervention based on the accurate prediction, we aspire to enhance the patient outcome, preserving the vision and improving the overall quality of life for individuals at risk of glaucoma. And our primary goal is to develop a precise and efficient glaucoma detection system by utilizing the advanced architecture such as Inception ResNet V2, DesNet 121 and traditional CNN. These models will be trained on the diverse set of annotated retinal images to learn unique features associated with glaucoma. By rigorously evaluating and comparing the performance of each algorithm in terms of sensitivity, specificity, and overall accuracy, we aim to identify the individual strength. Additionally, we will explore the potential benefit of combining the prediction from the Inception ResNet V2, DenseNet 121, and CNN using an ensemble approach to improve the system's precision and reliability and early glaucoma detection. These are the basic requirements that are needed to build this project. The first one are software requirements that are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. The second one is hardware requirements. It consists of operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. And the step, the necessary Python libraries and the frameworks for the deep learning and the image processing are imported. Commonly used libraries like TensorFlow, Keras, NumPy and others will be included to facilitate the model training and the image manipulation. And the second one is importing the dataset. A collection of retinal images containing both normal and glaucoma cases is acquired and imported. This data set will be used to train the deep learning model to identify the pattern and features associated with glaucoma. And the third one is image scaling and processing. The imported retinal images undergo pre-processing to ensure that are standardized and suitable for the training. This step includes resizing the images to a consistent size, normalization of the pixel values, and necessary image enhancement techniques. And the fourth step is splitting the dataset. The dataset is split into the two subsets, a training set and the testing set. The training set is used to train the deep learning model, while the testing set is kept separate for evaluation. This separation ensures that the model performance is assessed on unseen data. And the fifth one is applying the algorithm. Three different deep learning algorithms like Inception ResNet V2, DenseNet 121, CNN are implemented. The first one is Inception ResNet V2 is a deep learning architecture that combines the strength of both Inception and the ResNet model. It utilizes the concept of residual connection from the ResNet to allow the easier training of very deep networks. Additionally, it incorporates the multi-branch architecture of Inception, enabling the network to capture the feature at the different scale. Inception ResNet V2 is known for its exceptional performance in image recognition tasks due to its ability to learn, integrate pattern and the representation of the images. And the second one is DenseNet 121, is a convolutional neural network that introduces dense connection between the layers. In DenseNet, each layer receives direct input from all the preceding layers, promoting the feature reuse and the dense information flow. This architecture reduces the number of parameters, enhance the gradient flow, and facilitate the training of very deep networks. DenseNet 121 is widely used for various image recognition tasks too. And the third one is CNN, that is Convolutional Neural Network, is a classical deep learning architecture specially designed for the image processing task. It comprises multi-layers including the convolutional layer for the feature extraction and the pooling layer for downsampling. The final layers are typically fully connected layer for classification. CNN are known for the ability to automatically learn and extract the meaningful features from the images, making them a popular choice for the image recognition task. While traditional CNN not have complex architecture like of Inception ResNet V2 or the DenseNet 121, they remain effective and widely used in various applications including the glaucoma detection. And the sixth step is training the model. The training process involves feeding the pre-processed retinal images into each algorithm and adjusting the model parameter to minimize the prediction error. The model's training involves multiple iterations to fine-tune the weight and bias and optimize the performance. And the next step is user gives input. The system is integrated into a web application using the Flask framework. This allows user to upload the retinal image through a user-friendly interface. And the next step is the given input is pre-processed for prediction. When the user submits a retinal image, the input image undergoes the pre-processing to align with the requirements of the trained deep learning model. This pre-processing step ensures that the user input is appropriately prepared for glaucoma prediction. And the next step is trained model is used for prediction. The pre-processed input image is fed into each of the trained deep learning models like of Inception ResNet V2, DenseNet 121, and CNN. Each model predicts the likelihood of the input image containing the sign of glaucoma. And the last one is final outcome is displayed. The predictions from all three models are collected and analyzed depending on the choose and ensemble method. The system consists on the given prediction to generate the final classification result, the outcome indicating whether the retinal image indicates the glaucoma or not or in the moderate or the severe level. In this way, we display to the user through the web application, providing a reliable tool for the early glaucoma detection. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the various files within it. The dataset folder containing of the folders like moderate glaucoma, no glaucoma and severe glaucoma, which containing of various images within each folder. And the output folder containing the training and the var folders containing of various images within it. And the static folder containing of the folders like of CSS, JavaScript images within it. And the template folder containing of the HTML documents like of home, index, notebook, result, sign-in and sign-up pages. And the upload folder containing of the images that will be used for testing the model performance. And the app is an py file which contains the information related to the front-end logic. It includes the code that is written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model HY files are used to store the information that will be loaded at the time of execution of the project that is used to perform the certain tasks such as predicting the new data. And the notebook is an IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database used to store the user information. And to execute the project, we build an Flask framework. And overall project code is present in the IPYNB file and contains the combination of the code, graph and output all in one place. For the execution, first we need to copy this code folder address and then open the Anaconda prompt. Here we need to change the first address of the code disk like F because our code folder is present in F disk, and then write a command cd space and paste this code folder address. By this it changes the directory to the code folder's path, and then write a command python space app.py. By this command, it executes the Python script and perform the runtime check for any syntax errors and the logical issues. And then click on enter button. After running the app.py file, the Flask framework will host the application locally at the default address like this. And we need to copy this address, local link, and then paste it on any web browser. I likely prefer to use Chrome, and then click on enter button. Here, this is the home page that uses the glaucoma detection using the deep learning. And then click on the sign in and sign up buttons are present. I am clicking on sign up button. Here it redirected to the registration page. We need to fill all these details to create this account, but my account is already registered, that's why I'm using the sign in button. It redirected to the sign in page containing the username and password. I'm entering the username as of admin and password too as of admin, and then click on add login button. Here it redirected to the index page containing of the choose file and the upload buttons, and I'm clicking on the choose file button. It redirected to the uploads folder that present in this code folder, and select any one of the image from it. I'm selecting this image, and then click on open button and click on upload button. Here it will be redirected back to the result page and predicted the result as moderate glaucoma. By using the try again button, we can redirect back to the index page and select the choose file button and select any one of the image, and then click on open button and then click on upload button. Here it redirected to the result page and use the prediction as severe glaucoma, and by using the try again button we redirect back to the index page, and by choosing the file button, here select one image and then click on open button and then click on upload button. Here it redirected back to the result page and view the prediction as no glaucoma. In this way we can predict the glaucoma detection by using the deep learning algorithms. And in conclusion, our project using the Inception ResNet v2, DenseNet 121 and CNN has yielded the promising result in the field of medical image analysis and deep learning. Through the implementation and the evaluation of these advanced algorithms, we have developed an accurate and efficient glaucoma detection. And this project successfully opens a venue for the early glaucoma diagnosis, empowering the eye care professional with a reliable tool for timely intervention and the vision preservation. Moving forward, our work holds the potential to make a significant impact in preventing the irreversible blindness caused by glaucoma.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.